Welcome to our comprehensive journey into exploratory data analysis, or EDA for short. In today's data-driven world, EDA is the crucial first step in understanding and preparing your data for deeper analysis. Whether you're a beginner or looking to refresh your skills, this video will guide you through the essential concepts, techniques, and tools that make EDA so powerful. We'll start by exploring what EDA is, why it matters, and how it fits into the broader data analysis process. By the end, you'll have a solid foundation to confidently tackle any dataset. Let's dive in and unlock the secrets hidden in your data. Exploratory data analysis is a process of investigating datasets to summarize their main characteristics, often using visual methods. It's about getting a feel for your data before making any assumptions or building models. EDA helps you spot patterns, detect outliers, and uncover relationships between variables. By exploring your data thoroughly, you can make more informed decisions about which analytical techniques to apply next. EDA is not just about numbers, it's about telling the story behind your data and preparing it for further analysis. Before jumping into complex models or algorithms, it's essential to understand the data you're working with. EDA provides the foundation for all subsequent analysis by revealing the underlying structure, trends, and anomalies in your dataset. It helps prevent costly mistakes, such as building models on flawed or misunderstood data. By investing time in EDA, you ensure that your insights and predictions are based on accurate, well-understood information. This step is crucial for anyone serious about data science or analytics. EDA process typically follows a structured workflow. It starts with data collection, followed by cleaning and preprocessing. Next, you perform initial analyses to understand distributions, relationships, and potential issues. Visualization plays a key role throughout, helping you see patterns and anomalies that might be missed in raw numbers. Finally, you summarize your findings and prepare the data for modeling or further analysis. Each step builds on the last, ensuring a thorough understanding of your dataset. Every EDA journey begins with data collection. This step involves gathering relevant data from various sources, such as databases, spreadsheets, or APIs. The quality and scope of your data at this stage will directly impact your analysis. It's important to ensure that the data is representative of the problem you're trying to solve. Sometimes, you may need to combine multiple datasets or perform initial checks to verify completeness. With your data in hand, you're ready to move on to the next step. Once you've collected your data, the next step is cleaning. Real-world data is often messy, with missing values, duplicates, or errors. Data cleaning involves identifying and correcting these issues to ensure your analysis is accurate. This might mean filling in missing values, removing duplicates, or correcting inconsistencies. Clean data is the foundation of any reliable analysis, so don't rush this step. Take the time to understand and address any problems before moving forward. Reprocessing goes hand in hand with cleaning. It includes transforming data into a suitable format for analysis. This might involve normalizing values, encoding categorical variables, or scaling features. The goal is to make your data consistent and ready for exploration. Preprocessing ensures that your analyses and visualizations are meaningful and comparable across different variables. With well-prepared data, you can confidently move on to deeper exploration. Key part of EDA is understanding the types of data you're working with. Data can be numerical, categorical, or even textual. Each type requires different handling and analysis techniques. For example, numerical data can be summarized with statistics like mean and median, while categorical data is often explored with frequency counts or bar charts. Recognizing data types early helps you choose the right tools and methods for your analysis. Descriptive statistics are the backbone of EDA. They provide simple summaries about the sample and the measures. Common statistics include mean, median, mode, standard deviation, and range. These metrics help you quickly understand the central tendency and spread of your data. By calculating these values, you gain insights into the overall structure and variability of your dataset, setting the stage for deeper analysis. Visualization is a powerful tool in EDA, especially for understanding distributions. Histograms, box plots, and density plots are commonly used to see how data is spread out. These visuals can reveal skewness, outliers, and patterns that might not be obvious from statistics alone. By visualizing distributions, you can quickly spot areas that need further investigation or cleaning. Outliers are data points that differ significantly from others in your dataset. They can indicate errors, rare events, or important variations. Identifying outliers is a key part of EDA as they can heavily influence your analysis and models. Techniques like box plots and z-scores help you spot these unusual values. Once identified, you can decide whether to investigate, correct, or remove them based on your analysis goal. EDA isn't just about individual variables, it's also about exploring relationships between them. Scatter plots, correlation matrices, and cross-tabulations help you see how variables interact. These insights can reveal hidden patterns, dependencies, or even potential causal relationships. Understanding these connections is vital for building effective models and drawing meaningful conclusions from your data. Correlation analysis measures the strength and direction of relationship between numerical variables. A high correlation suggests a strong relationship, while a low correlation indicates little to no connection. Correlation coefficients like Pearson's or Spearman are commonly used. Visualizing correlations with heat maps or scatter plots can make these relationships clearer and guide your next steps in analysis. Missing values are a common challenge in real-world datasets. EDA involves identifying where data is missing and deciding how to handle it. Options include removing rows, imputing values, or using algorithms that can handle missing data. The approach you choose depends on the amount and importance of the missing information. Addressing missing values early ensures your analysis remains accurate and reliable. Duplicate records can skew your analysis and lead to incorrect conclusions. During EDA, it's important to check for and remove duplicates. This process involves identifying records with identical values across key fields and deciding whether to keep or drop them. By ensuring each observation is unique, you maintain the integrity of your analysis and avoid misleading results. Feature engineering is the process of creating new variables from existing data to improve analysis. This might involve combining features, extracting information, or transforming variables. Well-crafted features can reveal new insights and boost the performance of your models. EDA helps you identify opportunities for feature engineering by highlighting patterns and relationships in your data. Large datasets often contain many variables, some of which may be redundant or irrelevant. Dimensionality reduction techniques like principal component analysis (PCA) help simplify your data by reducing the number of variables while preserving important information. This makes analysis more manageable and can improve model performance. EDA helps you decide when and how to apply these techniques. Categorical variables require special attention during EDA. Techniques like frequency tables, bar charts, and pie charts help you understand the distribution of categories. You can also explore relationships between categorical variables using cross-tabulations or chi-square tests. Proper analysis of categorical data ensures you capture important patterns and avoid misinterpretation. If your data includes time-based variables, time series analysis is an important part of EDA. Line plots, moving averages, and seasonal decomposition help you uncover trends, cycles, and anomalies over time. Understanding the temporal structure of your data is crucial for forecasting and modeling time-dependent phenomena. Text data presents unique challenges and opportunities in EDA. Techniques like word clouds, frequency counts, and sentiment analysis help you explore and summarize textual information. By extracting key themes and patterns from text, you can gain valuable insights that might not be apparent from structured data alone. A wide range of tools are available for visualizing data during EDA. Popular options include Matplotlib, Seaborn, and Plotly for Python users, as well as Excel and Tableau for more general use. Choosing the right tool depends on your data, your goals, and your level of expertise. Effective visualization makes your findings more accessible and actionable. Summary statistics provide a quick overview of your dataset. These include counts, means, medians, minimums, maximums, and standard deviations for each variable. By reviewing these statistics, you can spot potential issues such as unexpected values or inconsistencies and gain a better understanding of your data's overall structure. Data imbalance occurs when certain categories or classes are overrepresented in your dataset. This can bias your analysis and models. During EDA, it's important to check for imbalance using bar charts or frequency tables. If imbalance is detected, you may need to apply techniques like resampling or weighting to address it before modeling. Multivariate analysis involves exploring relationships between three or more variables. Techniques like pair plots, parallel coordinates, and clustering help you uncover complex patterns and groupings in your data. Multivariate EDA is especially useful for high-dimensional datasets, where interactions between variables can be subtle but important. Pivot tables are a powerful tool for summarizing and exploring data. They allow you to quickly aggregate values, calculate statistics, and compare groups. Pivot tables are especially useful for categorical data, helping you spot trends and patterns that might otherwise go unnoticed. With advances in technology, many EDA tasks can now be automated. Tools like Pandas Profiling, SuiteViz, and DataPrep automate the generation of summary statistics, visualizations, and reports. Automation saves time and ensures consistency, but it's still important to review results and apply your own judgment. Even experienced analysts can fall into common EDA traps. These include ignoring missing values, overlooking outliers, or misinterpreting visualizations. It's important to approach EDA systematically and double-check your work. Being aware of these pitfalls helps you avoid mistakes and ensures your analysis is robust and reliable. Good documentation is essential for reproducibility and collaboration. Keep detailed notes on your EDA process, including the steps you took, the issues you found, and the decisions you made. This makes it easier to revisit your work later or share it with others. Clear documentation also helps you communicate your findings effectively. Once you've completed your EDA, it's time to report your findings. Summarize key insights, highlight important patterns, and present your visualizations clearly. Tailor your report to your audience, focusing on actionable insights and recommendations. Effective reporting ensures your hard work translates into real value. EDA is the bridge between raw data and modeling. By thoroughly exploring and preparing your data, you set the stage for successful model building. Address any issues uncovered during EDA, such as missing values or outliers, and ensure your data is in the right format. With a solid foundation, you're ready to move on to predictive analytics or machine learning. Let's look at a practical example. Imagine you have a dataset of sales transactions. EDA would involve checking for missing or duplicate records, analyzing sales trends over time, and exploring relationships between products and regions. By visualizing sales distributions and identifying top-performing products, you can uncover valuable business insights. Another example, suppose you're analyzing customer data. EDA might include segmenting customers by demographics, exploring purchase behavior, and identifying churn patterns. Visualizations like bar charts and heat maps help you spot trends and target areas for improvement. This approach can drive better marketing and customer retention strategies. Healthcare datasets often contain sensitive and complex information. EDA in this context involves checking for missing or inconsistent records, analyzing patient outcomes, and exploring relationships between treatments and results. Proper EDA ensures data quality and supports evidence-based decision-making in healthcare. Financial data analysis often starts with EDA to assess trends, volatility, and risk. You might explore stock price movements, detect anomalies, or analyze correlations between assets. Effective EDA helps you make informed investment decisions and manage financial risk more effectively. Social media data is rich and varied, making EDA especially valuable. You might analyze post frequencies, engagement rates, or sentiment over time. Visualizations like line charts and word clouds help you uncover trends and understand audience behavior, guiding your social media strategy. IoT sensor data often involves large volumes and high frequency. EDA helps you detect anomalies, monitor trends, and ensure data quality. Techniques like time series plots and anomaly detection algorithms are especially useful in this context, supporting predictive maintenance and operational efficiency. In education, EDA can reveal patterns in student performance, attendance, and engagement. By analyzing grades, participation rates, and demographic information, you can identify factors that influence success and areas needing intervention. EDA supports data-driven decision-making in schools and universities. Retailers use EDA to understand sales patterns, inventory levels, and customer preferences. By exploring transaction data, you can identify best-selling products, seasonal trends, and opportunities for cross-selling. EDA helps retailers optimize operations and improve customer satisfaction. Transportation datasets can be complex with variables like routes, schedules, and passenger counts. EDA helps you analyze travel patterns, identify bottlenecks, and optimize routes. Visualizations like maps and flowcharts are especially useful for uncovering insights in transportation data. Environmental data analysis often involves exploring variables like temperature, pollution, and weather patterns. EDA helps you detect trends, monitor changes, and assess the impact of interventions. By visualizing environmental data, you can support sustainability efforts and inform policy decisions. Sports analytics relies heavily on EDA to evaluate player performance, team strategies, and game outcomes. By analyzing statistics like scores, assists, and possession times, you can uncover winning patterns and areas for improvement. EDA supports coaches, analysts, and fans in making data-driven decisions. Manufacturing datasets often track production rates, defects, and equipment performance. EDA helps you identify inefficiencies, monitor quality, and predict maintenance needs. By exploring these variables, manufacturers can improve productivity and reduce costs. Energy data analysis involves exploring consumption patterns, generation rates, and efficiency metrics. EDA helps you detect anomalies, optimize usage, and support sustainability initiatives. Visualizations like time series plots and heat maps are especially useful for energy data. Government datasets cover a wide range of topics from census data to public health. EDA helps policymakers and analysts uncover trends, monitor program effectiveness, and allocate resources more efficiently. By exploring government data, you can support evidence-based policy and improve public services. Congratulations, you've completed an in-depth exploration of exploratory data analysis. We've covered the key concepts, techniques, and tools that form the backbone of EDA. Remember, EDA is an iterative process. Each dataset brings new challenges and opportunities. Continue practicing these skills and you'll be well equipped to tackle any data analysis project with confidence. Thank you for joining us on this journey and happy analyzing.